Welcome to Embedded Edge, a podcast show hosted by Maurizio Di Paolo Emilio that brings life to some of the stories on embedded systems technologies and products featured on embedded.com and through other AspenCore media publications. In this show, you'll hear both engineers and executives discuss news, challenges and opportunities for embedded systems design in markets such as automotive, industrial, aerospace and consumer. Here is your host, Editor-in-Chief of Power Electronics News and Embedded.com, Maurizio Di Paolo Emilio.
Hello everyone and welcome to this new episode of Embedded Edge. Today we will talk about embedded antennas, innovations and insights into embedded antennas. And we have a special guest from Taoglas, a leading provider of advanced antenna solutions, who will dive deep into the technical aspects of embedded antennas and explore the innovations driving this field forward. Embedded antennas are crucial components in modern wireless communication systems, enabling seamless connectivity in a wide range of applications, from IoT devices to automotive systems. In this episode, we will cover the design principles, material choices, and integration challenges that define the performance and the reliability of these antennas. We will also discuss the latest advancements in antenna technologies and how Taoglas is at the forefront of these developments. Our guest is Dermot O'Shea, CEO and co-founder of Taoglas. Dermot has been working in the global electronics industry since 1997. A graduate of science from University College Dublin, Dermot has also completed the graduate courses in business, computing and enterprise development from Dublin Business School, Griffith College and Waterford Institute of IT, respectively. So let's talk with Dermot. Hi Dermot, thanks a lot for being here. How's it going?
Good, Maurizio, and yourself. Happy New Year.
Happy New Year. Thanks a lot for being here. So where are you located, Dermot?
I'm in San Diego right now in our corporate headquarters.
Good. So today we will talk about innovations and insights into embedded antennas. So I have prepared a couple of questions for you. So before that, can you introduce yourself? What inspired you to found your company, Taoglas, to focus on embedded antennas?
Hi Maurizio, thanks very much. My name's Dermot O'Shea and I'm CEO of Taoglas. We founded Taoglas 20 years ago to focus on, we started with GPS antennas because we saw a huge opportunity in the market for somebody to do custom antennas and services to companies that were not in consumer electronics. So there was lots of antenna companies for cell phones and laptops, but not for all the other M2M devices, we called them at the time.
Good. So can you give us an overview of the different types of embedded antenna that your company is offering? What are some of the key applications for these antennas?
Yeah, so we have over 1,000 embedded antenna part numbers, and about half of those would be cellular, and about another quarter of those would be GNSS. The rest are then a mixture of Wi-Fi, LoRa, Bluetooth, NFC, etc., etc. So they're really any embedded antenna that you would need for an IoT or a connected device. So mainly cellular is the main challenge, I suppose, customers have. So that's why we've so many of those. The reason being there's so many bands inside and so many different countries that you may want to operate in. So that's why we've got so many of them.
Good. So the choice of materials would impact antenna performance. So what materials are commonly used in embedded antennas and how these would affect the performance?
Yeah, so the material is very important. Like, about 25% of our research into antenna design is actually material design. There's lots of new materials coming out all the time. And there's some very advanced materials that you can use to increase performance, but they're often reserved for, mission critical, more expensive use cases like space. The traditional kind of day-to-day devices that we use, you're trying to find a balance between cost and performance. So we would end up with, traditional FR4 is used quite a lot, flex polymer antennas, ceramic antennas. In Taoglas, we have our own electro-ceramic mix and material. We also have another lighter weight version called Terrablast. So we use metal, traditional bent metal and cut copper as well. So it's still some of the old traditional materials, sometimes combined with new materials, but we're always researching it. Last year, we launched our invisible antenna line that's using a brand new material that just wasn't possible before. So it's a critical area, always, excited about new material innovations. But at the same time, we've probably tested 100 different types of material that we were not able to use for various reasons.
So another topic is simulation. Simulation and testing are important for validating antenna design. So what simulation tools and techniques does Taoglas use to design and optimize antennas?
Yeah, so we use, always use the latest in electromagnetic simulation software. Taoglas currently uses CST, but sometimes customers would have us use their software if they can't use or incorporate CST. So there's other ones like ANSYS and FFS, etc., and FICO. But we use CST. So we'd often, any new design, we start with the simulation. On the mechanical side, we have 3D simulation software as well. We use SolidWorks. There's other ones you can use too. We use, PCB routing software from Altium. So they're the main three that we probably use to get a product into production. But you mentioned test, and test is really critical for antennas. We have to test simulated performance, and then we test actual performance. And then even in production, we have to test all components before we use them. And then we test every single antenna before we ship it. So the testing is critical. The simulation is, I would say, about 20% of the design process.
So another question is about integrating antennas into device. So this can present various challenges. So what are the common challenges faced when integrating embedded antennas into devices for different applications?
Yeah, like there's two main challenges, right? One is the mechanical challenge. Like, how much size do you have? Where are you going to fit the antennas? Where's the battery? Where's the LCD? Where's the screen, etc. Especially today with all the different wireless technologies we put in any product, the biggest demand on PCB real estate will probably be the antennas. Everything else is getting smaller. But you're putting more antennas in there, so you need more space for antennas. And quite often, antennas for that perspective can be an afterthought because the customer's more focused on the LCD size or the battery size, etc. And then the second one is noise and interference. So the big challenge is, there's a lot of stuff packed in any product today. There's going to be noise, emissions coming from the other components, and trying to combat that, get away from it, shield it, work around it is always a big challenge. So they would be the main two.
So when you are designing antennas for multiple frequency bands, so this would require careful consideration. So how do you design antennas to operate efficiently across multiple frequency bands?
Yeah, so this is where really the skill of the antenna engineer comes into play. Like the theory and can get you, and the simulation, it's easy to, let's say, well, not easy, but in comparative terms, it's easy to design a single band antenna. Where it becomes difficult is multi-band antenna situations, because it's very difficult to simulate that. It's very difficult to just apply the theory to that. So the key behind this is two things for the engineer. One, the experience. How much experience do they have, getting over these challenges? And two, then, is creativity. I know some people call RF and antenna design black magic. I call it creativity. How can an antenna engineer think about this challenge? How do they get around it? How do they come up with a new way to design a multi-band antenna in the environment that they have? Because sometimes, when you improve the performance on an upper band, the lower band suffers, or vice versa. So trying to create a balance across all the bands is always very difficult.
So environmental factors can also affect antenna performance. How do environmental factors such as temperature, humidity, and physical obstructions impact antenna performance?
Yeah, like all of them can destroy your use case, to be honest. Like we've seen, antennas in the field, get completely obliterated by environmental situations. Sometimes it's been the reason that we've gotten an opportunity with a customer. So particularly like in cold environments, traditional like ABS plastic can smash very easily if a cable hits it or a bird hits it. Also when it's cold and you wash the antennas with warm pressure jets, there can be, water ingress is way more likely. You can see, buildup of water inside the antenna, and that deteriorates everything over time. Installing it in harsh environments, like we see some people do, things that should be obvious, like putting it inside a metal box, right? But sometimes you can put it beside devices that are also very noisy, and then it can saturate your radio module when you're trying to transmit. So you really need to consider everything. Heat as well, high temperatures. If you have a black antenna and it's on top of a black car in Arizona in the summertime, have you thought about that when you're selecting the antenna? And usually what happens is, people don't really plan for that. They didn't envisage that they would have business in Alaska, for example, and then, after a couple of years it happens. So we like the customers that, have probably learned the hard way a little bit and want to design and plan for all scenarios so that they're covered in the event that it happens. So it's we learn something new every day from the environmental challenges, that's for sure.
Thank you. So advanced technologies like MIMO and beamforming are transforming antenna capabilities. So what role do advanced technologies like MIMO beamforming play in embedded antennas?
Yeah, so like it's a key part of our research and development. Like we do, with millimeter wave, for example, there was an operator in North America bought millimeter wave spectrum. So we did a lot of beam steering and beamforming and massive MIMO antenna array projects that we thought may be required for cellular. It was in the 27, 28 gigahertz band. And it's a very interesting area. It's really interesting to see what's possible, that really a lot of areas of the network we can steer the cellular beams to, and now vice versa, so that you're not each time, I suppose, wasting some of the radiation pattern by pointing your antenna radiation pattern just in all directions. Rather than doing that, you can switch, you can sense which direction the signal is coming from, and then steer all the radiation pattern in the direction of where you're getting your signal from, and hence increase your gain and hence increase your throughput. I think at the moment, a lot of those solutions are probably overkill for the application because they're still quite expensive. They add some cost. You need more space for the antennas to implement the MIMO system. But it's something that's, we've seen in higher end use cases like aerospace and defense. Also maybe something that's mission critical that needs video transmission. But apart from that, it's still, overkill for a lot of people's use case and not required. But it's a really interesting area. It's also, it uses more power as well as increasing cost, so it's that balance of, how much do I need it versus how much does it cost? And at the moment it does cost a lot. So we're not seeing it, a lot of it, but we've definitely done, 10, 12 projects in that area. And it's really, really interesting. It's a capability that we have. And I think it's something that our engineers really enjoy doing, because it's very challenging and it's a great learning experience. So we'd love to do more in that area, that's for sure.
Yeah, lots in terms of antenna is everywhere. So great job. So in conclusion, Dermot, my last question. So finally, the future of embedded antennas is shaped by emerging trends. So what trends, emerging trends, and technology do you see for the next future influencing the future of embedded antennas?
Yeah, well, if you look at the stock market, the darling of the stock market is NVIDIA right now. And they're telling us about the implementation of AI is about to really start in earnest. And they're calling the hardware physical AI. So, I would say we're at the forefront of physical AI. So autonomous driving, robotics, that's about to take off. Like we've seen it with lawnmowers and drones, autonomous lawnmowers, drones, warehouse robots, and they work really, really well. And I've seen like somebody who's deployed warehouse robots, for example, it's been successful and they've just deployed more. And not only have they deployed more robots, they've increased the wireless functionality in each one and need more antennas. So I think, for safety, for redundancy, for performance, this physical AI wave that they're predicting is coming will need a lot of antennas. So we're excited about that. That was the buzzword of CES 2024. It's 2025 now. Of CES 2025 was physical AI. So we're not an antenna company anymore. We're a physical AI company. We're jumping on that bandwagon.
Great. So thank you so much, Dermot. It has been a pleasure to have you. Thanks a lot for joining us at Embedded Edge, and have a good day. Thank you.
Thank you, Maurizio. Appreciate it.
That brings us to the end of this episode. Stay tuned for more news and technical aspects about embedded systems design. If you are listening to this on the podcast page at eetimes.com or embedded.com, links to articles on topics we have discussed are shown on this page. Embedded Edge is brought to you by Aspen Core Media. The host is Maurizio Di Paolo Emilio, and the producer is James Eade.